All right, so in this video, I'm going to review some statistics with you guys. And one of the first things that you guys learned in Math 1 is called a scatter plot, right? And a scatter plot is just a graph of a set of data points or data pairs. And your data can be anything, right? It could be the number of subscribers in your x-axis and the number of sales based on the number of subscribers, right? It could be shoe size in your y-axis as to the number of students, right? And so over here, right, a scatter plot looks, if I draw some scatter plot points, they're all kind of scattered all over the place, right? As the name implies, it doesn't look like it matches or it's on a specific line, okay? So over here, right, this would be actually called a negative correlation. And why do we call it a negative correlation? On this first example of my scatter plot, right, as I increase my x, my y value tends to decrease, right? So you think of it as a negative slope. And over here, right, if I plot in this middle graph, just some random points, right? It looks like this one has zero correlation, okay? So no correlation. Correlation, as the name implies, it just means like there's no relationship, okay? And on this last scatter plot right here, right, you would probably estimate or predict that this is called a positive correlation. Okay, so what's a positive correlation? As x increases, right, so does my y. Okay, so roughly, right, because again, it's a scatter plot, it models a real world. Not many things in the real world model a perfect line, okay? So that's why we call it a scatter plot. All right, now, the next vocabulary term that you may or may not have heard is called a line of best fit. And in this course, I'm just going to abbreviate line of best fit as LOBF, right? It's a mouthful. It takes a while to write all that. I'll just abbreviate LOBF. It's a line that passes through a scatter plot with roughly equal points above and below it. Roughly, right? That's the key word. So if I ask you to go back in your scatter plot and draw a line of best fit, how would you do that? Well, you would probably use a straight edge, right? But roughly, my line of best fit for this first graph would look something like this. Okay, so there's my lob, right? Roughly points above it, roughly the same number of points below it. On this one, you can't draw a line, right? Because there's no correlation. Okay, let me just add a few more points. Okay, it doesn't even look like a line. But this one, clearly, if I were to draw a line of best fit, it would look something like this, right? Roughly equal amount of points above it and below it. Okay, so that's your line of best fit. All right, the last terminology that I'm going to cover with you guys is called the correlation coefficient. It is a number to indicate how strong a relationship is between two variables. Okay, in this case, our two variables are x and y, and it's your R value. And your R is a number that is between 1 and negative 1. Okay, this is called your correlation coefficient. We call it RCC. And I'm going to go back to our graph over here. Your correlation coefficient is typically on a scale, right, from -1 to +1. So if it's a negative correlation, your R value is close to approximately -1. If there's no correlation, your R value is going to be 0. And if there is a positive correlation, your R value is approximately close to +1. Okay, so that's what your R value basically tells you, how strong a correlation there is between the two data points. If it has a positive slope, R is close to 1. If it has a negative slope, R is approximately close to -1. And if there's no correlation, R value is approximately close to 0. Okay, so that's a little bit of vocabulary on what a scatter plot is, what a line of best fit is, and what a correlation coefficient is. Okay, it's fairly straightforward. It's also in your textbook in case you don't find this video to make much sense.